Announcing the arrival, Deputy Vice Chancellor, Academic and International of University Malaysia Perlis kindly request everyone to please rise. UniMAP official song, Wawasanku. Ladies and gentlemen, please be seated.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. قل اللهم مالك الملك تؤتي الملك من تشاء وتنزع الملك ممن تشاء وتنزع الملك ممن تشاء وتعز من تشاء وتذل من تشاء وتعز من تشاء وتذل من تشاء بيدك الخير إنك على كل شيء تولج الليل في النهار وتولج النهار في الليل وتخرج الحي من الميت وتخرج الميت من الحي وترزق من تشاء بغير حساب صدق الله العظيم.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon. Salam ilmu, keikhlasan, kecemerlangan UniMAP. Salam Malaysia Madani. The Honorable Professor Insinyur Dr. Muhammad Shukri Abdul Majid, Deputy Vice Chancellor Academic and International, University Malaysia Perlis, Associate Professor Technologies Dr. Nur Hafiza binti Muhammad, Chairman of International Conference on Digital Transformation and Emerging Technologies Icdtet 2026 and participant contact UniMAP Erasmus Plus Capacity Building in Higher Education Grant Project Get Innovative for Impact. I would like also to warm welcome our distinguished keynote speaker and guest, Technologist Dr. Salfarina binti Rosman, Head of Department Research and Development from PHN Industri Sdn Bhd, Mr. Muhammad Nizam Najmuddin, Senior Industrial Designer from MIMOS Berhad, Professor Dr. Muhammad Wasif, Director Quality Enhancement Cell from NET University of Engineering and Technology and member of Project Get Innovative for Impact, Professor Dr. Syed Amir Iqbal, Dean Faculty of Mechanical and Manufacturing Engineering, NET University of Engineering and Technology and member of Project Get Innovative for Impact, Associate Professor Insinyur Dr. Asnul Hadi bin Ahmad, Participant Contact Project Get Innovative for Impact, University Malaysia Pahang Al Sultan Abdullah, Dr. Abdullah Mangal, Participant Contact Project Get Innovative for Impact, Buluchisan University of Engineering and Technology Pakistan, Dean and Head Department of Faculty, distinguished guests, Icdtet 2026 participant, ladies and gentlemen. Welcome to the opening ceremony, International Conference on Digital Transformation and Emerging Technologies, Icdtet 2026. This conference, organized by University Malaysia Perlis, Erasmus Plus Capacity Building in Higher Education Grant Project Get Innovative for Impact and co-organized by UniMAP TVET Center. Ladies and gentlemen, Icdtet 2026 offer a dynamic platform for knowledge sharing, collaboration, and innovation in digital transformation. Whether an expert or emerging talent, this event expects insightful discussion, meaningful connection, and fresh perspective as we shape the future of technology together. Ladies and gentlemen, without further ado, I would like to call upon Associate Professor, Technologist Dr. Nur Hafiza binti Muhammad, Chairman of International Conference on Digital Transformation and Emerging Technologies, Icdtet 2026, to deliver her welcoming speech. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon everyone. Salam ilmu, keikhlasan, kecemerlangan UniMAP. Salam Malaysia Madani. Professor IR Dr. Muhammad Shukri Abdul Majid, Deputy Vice Chancellor Academic and International. TS Dr. Salfarina binti Rosman, Head of Department Research and Development, Keynote Speaker from PHN Industri Sdn Bhd. Mr. Muhammad Nizam Najmuddin, Senior Industrial Designer, Keynote Speaker from MIMOS Berhad. Professor Dr. Muhammad Wasif, Director, Quality Enhancement Cell, Keynote Speaker from NED University of Engineering and Technology, and also member of Project Get Innovative for Impact. Professor Dr. Syed Amir Iqbal, Dean, Faculty of Mechanical and Manufacturing Engineering, NED University of Engineering and Technology, and also member of Project Get Innovative for Impact. Associate Professor IR Dr. Asnul Hadi bin Ahmad, Participant Contact UMPSA for Project Get Innovative for Impact. Dr. Abdullah Mangal, participant contact for Balochistan University of Engineering Technology, Project Get Innovative for Impact, respective deans of faculty and head of departments, organizing committee of TVET 2026, participants, students, ladies and gentlemen. Alhamdulillah, all praise is due to Allah Subhanahu wa Ta'ala for granting us the opportunity to assemble here today. So on behalf of the organizing committee, it is my great pleasure to welcome you to International Conference on Digital Transformation and Emerging Technologies 2026. This conference is organized by the Faculty of Mechanical Engineering and Technology, University Malaysia Perlis, in collaboration with UniMAP TVET Center, with the big support from Erasmus Plus Capacity Building in Higher Education (CBHE), Project Get Innovative for Impact title Implementation of Digital Transformation Practices through the capacity building of occupational and industrial stakeholders in Pakistan and Malaysia. I would like to take a moment to highlight the strategic significance of the Erasmus Plus Get Innovative for Impact project, which serves as a cornerstone of our gathering for today. Funded by the European Union, this project represents a consortium between universities in Europe, Malaysia, and Pakistan. Its primary mandate is to drive institutional modernization by integrating digital transformation and smart manufacturing technologies directly into higher education curricula. Through this establishment of centers of excellence in our university and also in other partner university, and also the development of industry-aligned modules, this project is actively bridging the gap between academic theory and industrial application, ensuring our institutions remain at the forefront of the technological innovation. We are gathering our industrial partner together in this platform today. I'm also delighted to acknowledge the presence of our students from the Get Innovative for Impact ecosystem who have developed impressive projects under this initiative and also involved in student competition past October. Furthermore, we are proud to have also student participants who will be showcasing their research findings tomorrow during the poster presentations and parallel sessions of the conference. This conference also part of the initiative under Get Innovative for Impact. This is not the first conference that we had organized. This is the third edition of annual conference under Get Innovative for Impact. The first conference was organized in 2024 in LED University of Engineering and Technology, and the second conference was successfully organized last year in UMPSA. Aligned with the objectives of Get Innovative for Impact, Icdtet 2026 is anchored by the theme Transformative Research in Digital Innovation and Technology Change. By bringing together researchers, academics, industry, practitioners, and professionals, the conference fosters rigorous academic discourse and knowledge exchange across multidisciplinary domains. The technical program of this conference covers a broad spectrum of conference tracks, including digital transformation, artificial intelligence, machine learning, simulation and modeling, sustainable and smart manufacturing, and sustainable infrastructure. These tracks reflect the interdisciplinary nature of contemporary research and the evolving demands of global technological development. We have received more than 100 papers for this conference, and it is our hope that this conference will serve as a valuable platform for the intellectual exchange, foster future collaborations, and contribute meaningfully to the advancements of digital transformation and emerging technologies. To all authors, presenters, reviewers, participants, students, thank you for your valuable contributions and for being part of Icdtet 2026. I hope this conference will be a meaningful and rewarding experience for you. I look forward to fruitful deliberations and impactful outcomes. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Associate Professor Dr. Nur Hafizah, for the welcoming speech. Now, I will be honoured to call Professor Engineer Dr. Muhammad Shukri Abdul Majid, Deputy Vice Chancellor, Academic and International University Malaysia Perlis, to deliver his opening speech. Prof, please welcome.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to everyone. Okay, salam ilmu keikhlasan Kemenangan UniMAP, salam Malaysia Madani, Associate Professor Technologies Dr. Nur Hafizah binti Muhammad, Chairperson for the Icdtet 2026, Technologist Dr. Salfarina binti Rosman, Head of Department Research and Development, PHN Industries Berhad, Mr. Muhammad Nizam Najmuddin, Senior Industrial Designer, Mimos Berhad, Professor Dr. Muhammad Wasif, Director Quality Enhancement Cell, NED, University of Engineering and Technology, Professor Dr. SYED Iqbal, Dean Faculty of Mechanical and Manufacturing Engineering, NED, University of Engineering and Technology, Associate Professor Engineer Dr. Asnul Hadi bin Ahmad, Institution Pahang, Sultan Abdullah, and then Dr. Abdullah Megal, Balochistan University of Engineering and Technology, Pakistan, and all the organizing committee of Icdtet 2026, all the participants, and last but not least, all ladies and gentlemen. Alhamdulillah, let us express our gratitude to Allah Subhanahu wa Ta'ala for allowing us to gather here today for this event. It is indeed a great pleasure for me to welcome all esteemed keynote speakers, invited speakers, participants, students, distinguished guests, and all attendees to the International Conference on Digital Transformation and Emerging Technologies 2026. I would like also to extend a warm welcome to the CAT Innovate for Impact team, a project under the Erasmus Plus Capacity Building in Higher Education program. We are honored to collaborate with such a dedicated team. We are privileged to host this distinguished lineup of speakers for Icdtet 2026, representing international institutions and industries. We are also delighted to feature our industrial keynote speakers from PHN Industries Berhad, a subsidiary of DRB Highcom Berhad that specializes in automotive components manufacturing. Additionally, we are privileged to host a keynote speaker from Mimos Berhad, and their participation underscores the vital collaborations between university and key industry players. Ladies and gentlemen, digital transformation today is no longer a matter of choice, but it is a strategic necessity. The rapid advancement of emerging technologies such as artificial intelligence, advanced simulations, data analytics, automation, and smart systems is reshaping how we educate, conduct research, and address complex societal challenges. In this context, I believe Icdtet 2026 is more than just an academic gathering. It serves as a strategic platform for scholars, industry leaders, and policymakers to exchange ideas, align research with global priorities, and explore solutions that create tangible impact. Ladies and gentlemen, This conference is organized under the Get Innovative for Impact project, as mentioned by Dr. Nohafiza earlier, a project co-funded by a European Union aimed at strengthening institutional capacity, promoting innovation-driven education, and fostering impactful international collaborations. This overarching theme of the project is digital transformation. The project under the Erasmus Plus capacity building is led by the NED, University of Engineering and Technology in Pakistan, together with partners university from Pakistan, Malaysia, Ireland, and Italy. The consortium has been awarded a grant worth more than 700,000 euros. So these platforms such as Icdtet, UniMAP continues to strengthen its role as the internationally engaged technical university, bringing together scholars, industry practitioners, and institutions from diverse regions to co-create knowledge, share expertise, and expand transnational research networks. Ladies and gentlemen, we are deeply honored to host delegations from Pakistan as well as participants from various institutions across Malaysia, Asia, and Middle East. Your presence reflects not only academic collaborations but also a shared commitment to regional developments and global knowledge exchange. I am pleased to share that the Icdtet 2026 has successfully accepted more than 100 research papers contributed by scholars from over 20 universities and institutions worldwide, with 100 of participants attending this conference. The research presented addresses critical areas including digital transformation, artificial intelligence, simulation and modeling, sustainable manufacturing, renewable energy, healthcare technologies, and many more. Ladies and gentlemen, before I end my speech, allow me to once again extend my gratitude to all the organizing committee members, sponsors, researchers, and everyone involved in this, making this Icdtet 26 a successful one. It is my sincere hope that this Icdtet 2026 will serve as a catalyst for sustained collaborations, joint research initiatives, and meaningful international academic engagement that extends well beyond this conference. On that note, with Bismillahirrahmanirrahim, it is my greatest pleasure to officiate the opening of the International Conference on Digital Transformation and Emerging Technologies 2026. With that, I hope you enjoy the conference for the next couple of days. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Prof. Please remain on the stage. We will continue with a token of appreciation to our distinguished guests. I would like to invite Associate Professor, Technologist Dr. Nur Hafiza to accompany Professor Dr. Muhammad Shukri on the stage. Please welcome Professor Dr. Muhammad Wasif. Technologist Dr. Salfarina binti Rosman. Professor Dr. Syed Amir Iqbal, representative from NTD University of Engineering and Technology. Abdullah Manga, representative from Balochistan University of Engineering and Technology, Pakistan. Associate Professor in Sino Dr. Azmul Hadi bin Ahmad, representative from University Malaysia Pahang, Al Sultan Abdullah. The delegation to the stage for a photo session before we proceed with the keynote speaker session. you very much, Prof. Dr. Muhammad Shukri. Ladies and gentlemen, we will continue with keynote speaker session. It is my pleasure to share a brief background of our first keynote speaker for today. Dr. Muhammad Wasif is a leading academic and industry expert in Industry 4.0 and smart manufacturing. He is a professor in the Department of Industrial and Manufacturing Engineering at NED University of Engineering and Technology, Pakistan, with a PhD in CAD/CAM from Concordia University, Canada, and having more than 20 years of academic and research experience. His work has significantly advanced digital transformation and industrial automation in Pakistan by effectively bridging research and industrial practice. Please join me in welcoming Professor Dr. Muhammad Wasif from NED University of Engineering and Technology, Pakistan, to share his research titled Industry 5.0 Unleash Human-Machine Interaction Requirement and Challenges.
Thank you. Bismillahirrahmanirrahim and Assalamu alaikum wa rahmatullahi wa barakatuh. So I'll be starting my presentation, and that's about Industry 5.0, that is unleashing, and of course it's the future technologies, and presentation is not so visible. So these are the contents of my presentation. I'll be starting with little introduction about what are the problems around us, what are the current challenges to the third world and advanced countries as well. Then I will discuss about the current requirements and needs as chalked out by the World Economic Forum. Then I will discuss about the Industry 5.0 technologies, that how the technologies are evolving and changing, and how it is being affected all over the lives. And finally, our work, what we are doing at NED University of Engineering Technology. So if I start with the first slide, that is the problems and challenges to the third world countries. So you can see that the major problem is about the environment, that what is happening with the factory, what type of effluents are coming, what are the different pollutions which are being emerging from different industries. That is the major problem. Our industries are very labor intensive, and it needs the people to work by hands and doing assembling and stitching and these sort of work, which is very difficult to grab. Next thing is the bad working habits, and due to the bad working habits, our people are getting different types of illnesses, wounds and diseases which are causing them the damages to their bodies, and they are becoming very vulnerable to these situations. The uncertainty in the market, how the inflation is going on, what are the different changes in the banking system, the digital currencies, and the fintech which is coming all around us, and our systems are not embracing those challenges. Then we have wastage of resources, how to track the resources and how well the resources are being utilized. That is another challenge. Then we have obsolete skills. There are several skills which are changed, and for the precision, different types of machines and equipments are used. For example, in Pakistan, we have a very big industry of sports good. We make the soccer footballs. But when we stitch it with the hands, then what happens that the sewing pattern and with all the threads inside, the weights are not balanced, which is balanced through the machines actually. So that is the reason that the industry is not emerging, but it's going down due to these reasons, because we are not adopting the new tools and techniques. We have also the problem of circular debt, because we have the debt all around our country due to the problem of you can say inflation and the time of the debt, and those are the major problems. If we want to see that what are the causes, next please. If we want to see the causes of these problems, then the major causes are due to these. Okay, please, if you, yeah, next please. So these are the major problems. No real-time, monitoring of the emissions. We are not able to emit the emissions, that how much nitrous oxide, carbon monoxides are being emitted from the factories, how much effluents are coming from the factories. And this is the problem which is making the disaster. Our waters and our environments are continuously being polluted. We have the lack of skills to use the modern tools. We have the problem of lack of real-time, productivity measurements, that how we can measure that how well a worker is doing work with the productivity. We have lack of market knowledge base, due to which we are not able to predict and forecast precisely. We do not have the resource traceability, that how we can trace the resources. We have obsolete curriculums and skills, due to which our industries are getting the problems, and poor market habits of long-term debts. So what are the solutions of these problems? Please, next. So the solutions are gathering real-time data for the emissions. If we have some sensors and IoTs embedded to the systems, we can easily monitor that how much emissions and effluents are being coming from the industries, and we can control that. If we use the modern tools and technologies, it will be efficient to measure the productivity and measure the time duration in which the works are done. Need of a smart workstation through which we can guide worker that you have to do the work in this way. We can measure that how the worker is doing work. We should have AI-based demand and market forecast. Real-time traceability of resources, tech-based courses and trainings are needed, and of course we need the real-time cost estimations. These are the major problems. And what are the solutions? Please, next. The solution is through the automation, and technologies, of course. Okay, digitalization, which is the need of time, and we have to embrace that. If we do not embrace that, we will be far behind the world. Next, please. So, in the digital era, if we go to the past, so I'll just explain to you that what is Industry 4.0 and 5.0. So if we talk about Industry 1.0, so it was at the time when the steam engine was invented. I hope that you know that how the steam engine was invented, and later on it was first time it was patented and it was used in the locomotive like railways and cars. And later on it was used by the factories to automate the systems, and it is back in 1800s. Then Industry 2.0 was started with the invention of electricity. As we know that electricity was the major thing which started to we started to use the motors. We used to start the hydraulics and pneumatics and so on. In Industry 3.0, it was started in 1970s when the personal computers were and the microchips were invented, and through which we can use the fixed automation. And that fixed automation means if you feed a program, it will work in the similar way again and again. Industry 4.0 started with the advancement of our network systems, especially advancement in the AI, in the cloud systems, and it was in 2000. And now people are talking about Industry 5.0. Next, please. So Industry 5.0 is something which is not yet been fully embraced, but it is something which is going to be, very soon it's going to be emerging all around us. And it talks about the human. It is basically related with the humans and how the human is going to interact with the machines, and how the machines are going to understand that what human is thinking and what they are expressing with their senses and minds. Another part is the sustainability, because in the Industry 4.0, it was totally machine dependent, it was totally AI dependent, and it was not so much well structured. But with the human and machine interaction, it will be made possible that we can make the system resilient and taking the action in accordance with the human mind. Next, please. So, if we go to the World Economic Forum report 2025, this is a job report and very current report. It says that these are the different aspects, these are the different, you can say that the fields in which the jobs are emerging, and these are the different domains in which jobs are needed. So it's about, you can say that in 2025 we need big data specialists, fintech engineers, AI and machine learning specialists, and so on. But you know that people do not need these fields separately. Like for example, some people who have only the knowledge of AI. No, it should be combined with different other domains like electrical engineering, like mechanical engineering, like industrial engineering, and so many other domains. So people need a complete package. Industries need a complete package. They do not need a very specialized person who will be working in only one domain. So these are the fields which are needed till 2029. Please go to next slide. In this slide, next slide. Yes, in this slide you can see that the clerical works are going to be diminished. Okay, industries don't need clerks. Basically, everything is going to be digital. If you go to the hotel in Europe or America, you have to check in yourself. If you go to the markets, you have to check out yourself. You have to scan everything, and the bills will be made, and so on. So these are the jobs which are going to be vanished in near 2 to 3 years, and so on. Next, please. The previous one. Okay, in this slide, the World Economic Forum says, the job report 2025 says that these are the different tactics which an engineer or a professional should have. And what are these tactics? You can see that it starts with the analytical thinking. Okay, it starts with the analytical thinking, critical thinking. You have to work analytically. Okay, then resilience, flexibility and agility, leadership and social influence, creative thinking. So these are the different types of characteristics and attributes which are needed to be embedded in the engineers and other professionals. And you can see that these are the things which are being slowly and gradually added in our curriculums, rather than teaching pure engineering and in a single domain. Next, please. So if we see the trends in the world, what is happening that Germany invent this terminology, which is called now Industry 4.0. Later on, the North America adopted it as a digital manufacturing or a smart manufacturing. And in our region, if we talk especially, please, next please. If we talk about Pakistan and other countries in this region, please next. Yes, so you can see that our countries adopted this technology very lately. We have only the policies, but we do not have you can say that a complete we can say that a complete framework to implement these sort of technologies. Next please. But we are not behind only. You can see that in North America, only the 36% industries has adopted the Industry 4.0 even. In the full Europe, 27% industries have adopted and gone towards the Industry 4.0. Whereas if we talk about the Asia, majorly China has adopted around 20% of their industries has adopted Industry 4.0. Whereas we have to see that where we are, Pakistan, Malaysia and other countries where we are. Next please. So what is Industry 5.0? Industry 5.0 is the inclusion of Industry 4.0 as well as the human-centered domain, sustainability and resilience. These are the three major domains which we have to include in the Industry 4.0 domain, so it becomes the Industry 5.0. Now, how these three domains are included and what are the effects of these domains in overall technology transformation, we are going to see in our next slides. So next please. Yes, so Industry 4.0 technologies. Now you will see the different technologies which are used in Industry 4.0. Artificial intelligence. Next. Yes, virtual and augmented reality. Next. Cloud services and wireless technologies. Still people are working on 8G and these sort of technologies to transfer the data in high rates so that they can use the artificial intelligence and autonomous vehicles and autonomous different types of techniques via this high-speed internet. Autonomous mobile robots, AMRs, which are very common in Europe and other countries and are being used in the industry. Next. 3D printing, additive manufacturing, which we are also using nowadays. Next please. Blockchain technology, which is very important to for the cyber security. Of course, these are the network-based systems, cloud-based systems, and it is a high potency of theft and hacking. That is the reason we should have blockchains and cyber security. Cyber physical systems, of course, we have to connect the softwares, AI, and these sort of things with the IoTs, so it becomes a cyber physical system. Next. Digital twin, which is very important. That previously we used to have the simulations, simple simulations, like we do the simulation on computer, but now what we do, we link that simulation with the actual world, so that if we change anything in the software, this change happens in the actual physical model as well. Next please. Collaborative robots are very common in Industry 4.0 technologies. Next please. And Internet of Things, of course. Without Internet of Things, nothing will work fine in Industry 4.0. Now I'm going to tell you that how these technologies are changed in Industry 5.0 and what is happening with all these technologies and how the human touch, resilience and basically the sustainability are being connected with these all technologies. Please next. So if we talk about artificial intelligence, previously we were talking about the artificial intelligence is something to which we train. We provide the data, it gets the data, it gets trained and it provides the predictions. We ask them that what will happen if this happens. So it is going to predict something and it is based on how we provided the data. But computers do not know the reasoning that why we provided this data, what happened for this particular instance so that this data come. For example, we have parameters and variable. I hope you guys know what are parameters and variables. So if an engineer change a parameter, it affects the variables. So why it happened, why a parameter is changed, computer do not know anything about this. Computer only know that this parameter is changed, so the variable is changed. So what is happening that now, please next. Now, the artificial intelligence is going to be changed to cognitive artificial intelligence. Okay. So what is cognitive artificial intelligence? It means that computer is going to, the AI system is going to understand the reasoning behind changing the systems. It is not making the decision only based on data, but also the reasoning that why this data is changed, what is happening, what was happened before, and how they are going to predict with the system. So this is called cognitive AI. So it thinks like human learning, and basically the reasoning and adapting to help make better decisions in complex world situations. So the direct applications of this cognitive AI in decision support systems, where we have to make decisions with the large data. For example, a company is going to invest in an industry. So how it is gonna invest in that industry based on the previous forecast and demand and everything. Predictive maintenance, that how a system is working and what are the failures that can happen, and how we have to take the remedial action so that the breakdown shouldn't occur. Human robot collaborations in cobot as well. We have to adopt this cognitive AI, and smart manufacturing in industry 5.0, other applications as well. This cognitive AI is going to be used, and of course, remember the word reasoning. So the AI system is going to understand that what are the reason behind having the data changed. Okay, next slide, please. Now, we have gone through these technologies which are called VR, AR, and MR. So these are virtual reality, augmented reality, and mixed reality. But what is happening now? It is going to be changed as extended reality. Next, please. So what is extended reality? Basically, it is also including the cognitive domain. A cognitive domain means that now XR is going to be embedded with the AI systems. Okay, so I hope you guys understand what is VR. VR is virtual world around us, which we make, which is not actually happened. What is AR? AR is basically augmented reality, that in real world we want to have some more information. So we have the AR. When we mix together these things, it become VR. But what is happening with the extended realities? Extended realities are going to mix the virtual and augmented reality and the actual world. That in the way, for example, I tell you one thing. For example, you are in a simulation where you are operating a machine, and if you link that machine with the physical system, so it's digital twin. But in VR, you are going to operate that machine, and actually that is going to be happen at that particular factory. For example, one doctor in US want to have an operation here in Malaysia or in Pakistan. So they are going to use one technology through which they do the operations. This is called haptics. So in haptics, what we are doing the things in the augmented way. We are doing something in US and operation is being conducted in Malaysia or Pakistan. But what is happening that there are some cognition behind. If doctor is going to take some action, then there is an advisor, AI advisor, which is going to tell that, okay, you should do this and be careful with this and so on. So this is called the extended reality, which is of course the major part of this industry 4.0, and it is currently being used in the education and training, healthcare, in industry, and there are several other domains which are going to adopt this XR. Next, please. Then we have cyber physical systems. So basically the cyber physical systems, what these are the link of AI systems, softwares and computers and different hardwares together. This is called the cyber physical system. But now what is going to be happening? Next, please. So it is going to be changed with the cognitive cyber physical system. It means that the system has the cognitive ability to understand and have the reason. So the system is going to tell that what resource is to be used and when. For example, if you have an 8-core computer, and within that computer, a few cores are needed, 2 to 3 cores. Then computer will use only 3 cores, and it will keep the 5 other cores remain silent, so the energy is being saved. In the same way, if we have a big industrial system and you are going to use some equipment based on the feedback and sensors, and the system thinks that if we operate only these machines, it will be optimally use the energy, then it's going to keep the other things in silent. So this decision will be based on not by the humans but by the machines, but in cooperation with the humans. So this is called cognitive cyber physical system. So it has also the several applications in this intelligent energy system, for example, in the smart grids, in autonomous and semi-automatic robots. For example, as you see the autonomous taxis, how it works that whenever there is a taxi which is near to a passenger, it will go directly to the passenger. The taxi which is far from the passenger, it will not go towards that. So it's already being in action. smart healthcare equipments, resilient supply chains. So these are the different applications of cognitive cyber physical system. Next, please. So if we talk about human interactions, currently in Industry 4.0 we are using cobots, collaborative robots. If you remember, in previous years we used to have the robots, and in robots what we did, we have the cages inside which the robots will work, and we try not to go inside the robot envelope, so that we are safe and we will not get any injury or wound. But what is going to happen with the cobots? Cobots are the collaborative robots and they sense the humans. But now what is going to be happened? There is one more thing which is just beyond the cobots, which are called HID. Please, next please. In the HID are called human interaction and recognition technique. It means that it is not going to only sense the body, but also going to sense your emotions. For example, if you make a sign like this, it means a stop. Human can understand it, but now robots are going to understand these things, that what you are saying, what you want to say, how expressive you are, and what your emotions are saying. So this technology is also being embedded in the facial recognition systems and are being trained to the robots. So here it is very common nowadays, and the applications are smart manufacturing and collaborative robots, virtual and augmented reality system. It means that if you are in VR and if you are discussing something with your friends, then your expressions on your face will be detected, and it will be as it is, it will be replicated in the VR systems. So it's something very important. Healthcare and rehabilitation, like we were discussing before, that there are some special children for which we need to have some systems who can recognize that what they are saying. So this system will make it enable to have the understanding of those people who cannot express their feelings and by the words and like that. Driver assistance in smart vehicles, and it will also be used in education, training, and simulations. So these are the emulgation of, you can say, that the technologies. Next, please. The other technology is called smart wearables. Next, please. Yes, we have IoTs which we were using, and IoTs are stationary. These are installed with some machines, and it gives us the data from those machines. And of course the IoTs are something which have the network as well. So network provides us the data that what is happening with the machine. But now what will happen, that we will be wearing some new items. Please, next please. So with this we will have the smart wearables. And what these smart wearables, these will be linking with the IoTs. Wherever you pass through the factory, it will be connected with the IoTs, and it will be gathering the data, and it will be providing you the real-time information about the machines on your smart glass or VR or these sort of equipment. Next, please. Yes, digital twin. Previously in Industry 4.0, we discussed about the industrial, digital twins, and digital twins are the combination of virtual and physical world. Next, please. Now, what is happening that these digital twins are linked with dynamic simulation and digital twin. It means that currently the digital twins are working in the way that if you operate something on virtual world, it will be changing the physical machine or physical thing. But now what will happen, that you can make the forecast, you can predict the things, and you can run the simulation for a long time, so that you can predict that what will happen with this machine. Okay, if this machine is running, it has several bearings, and if I run it for 8,000 hours, then what will be happening with the bearings? So it will be going to predict that on that time, along with the connection with the physical machine as well. So this is called DSDT. Next, please. Yes. So if we talk about the Industry 5.0, please, next please. Yeah, bring all things on the slide. So we have the enabling technologies, which are these Industry 5.0 new technologies. Then we have functional principle. It means that we are going to make smart everything, smart machines, smart stakeholders, smart customers, and of course modularity, standardization, and these are things. And based on that, what we are going to attain? We are going to attain 3 bottom lines. That is economic bottom line, environment bottom line, and social bottom line. So these are the objectives of Industry 4.0. As I discussed with you that how the sustainability and resilience are going to come. So basically sustainability and resilience are going to come through the economic bottom line, which is servitization. Servitization means that if you sell a machine to one of your customer, then your job is not ended. You have to be connected with that machine and with that customer through some software. So what is happening right now that if some machine is provided to you, then a cloud system is also provided to you, and you are continuously being connected with that machine and the system, that how it is operating and so on. And then you have productivity. Okay, you try to increase the productivity, you increase the economic growth and resilience, and how these are going to increase, of course, through these new cognitive technologies which are going to be embedded with the Industry 4.0 technologies. Environmental bottom lines, of course, circular economy, you are going to see that what thing is going to be ended and how we have to reuse it rather than going towards the breakdown maintenance and so on. Sustainable innovations, environmental preservations and renewable integration, these are the part of the environmental bottom line. If we talk about the social bottom line, human centricity, social development, social equity and job creations are the major requirement. As you see that most of the people are complaining that okay, industry 4.0 and 5.0 are going to basically decline the job market, but basically this is not. It's going to explore the new challenges, new problems. Whenever you have new technologies, you have new challenges, new problems, and you have new knowledge which you have to attain so that the world can go further. Next please. So now I'll tell you that what we are doing at NED University, we are working on the digital twin, and basically we made a prototype, and with that prototype we published a paper in a conference of American Society for Engineering Education. And with that prototype, basically what we did, we connected the whole system with a virtual system, and we can directly operate that machine through the computer model. And now our basically major work is to integrate a whole big CNC machine with all these domains like cutting force, vibration sensor, we have thermal camera, we have high speed camera. So we are going to operate that machine with a virtual model. And why we are doing that? Because we want to simulate first that how we can save the energy of this machine, how we can save the wear in the tool, and how we can optimally set the parameters so that we can get the good surface finish over the material and so on. So this is the work which we are doing with our some of the students. Next please. Then another domain of our work is a PhD work which is being now supervised by me, and this is what we are doing, that we are going to collect the psychosocial and psychocognitive factors and their impact over the whole organization or enterprise. That due to this technological changes, people are also getting much connected with the WhatsApp and computer and these sort of things, and due to which their social life is going to be changed. So we are going to measure that how complicated the technology is and what are the impact of that technology over their normal life, so that we can have the knowledge base and later on we can train it to the machine, and we can optimize that what work or what type of jobs should be given to a certain person so that he or she will not get retarded. Next please. So this is another invention of ours. This is called Smart Workstation, and a group of final year students made it. This Smart Workstation can be used, basically it is a kind of autopilot. It has a projector, it has a camera. So what happens that when you have to do the manual assembly, for example, if you go to pizza shop and there is some worker who is working there and he is not very well trained, so even he can make the pizza. How he can make the pizza? We feed the SOP in this machine, and this machine guides him that how to make the pizza. It will tell us that from where we have to take the material and how we have to make it assemble, and there will be a camera. It will be measuring the time, that in how much time this guy is doing work, and the KPIs will be measured and it will be sent to the managers. So whatever the assembly stations you have, you can replace it with this machine, and this machine can give you the information. This can also be used for the time motion study. Like you can also conduct the time motion study and you can get the standard times. Next please. Yes, another work, and that is for the wire cut, that one of our PhD student gathered the data especially for the Inconel, and she fed all the data to for the machine learning algorithms, and she made a code through which we can select that it can also be used for other machining process as well. That which of the machine learning algorithm will be suitable with the high precision, and you can get the optimal parameters for machining or wire EDM. Next please. Next please. Yes. One of our student group, two groups even, they are working to develop lean and health and safety games for the training purpose for the students. So basically they are developing these games in the VR technology so that the students can wear the VR and they can go inside some factory environment and they can find that what are the different waste within that factory, and they can they can provide their suggestions for the improvement, and this is how their levels are increased and they get some scores. So these are two games which we are making currently. Next please. There is another work which I couldn't mention, and that basically is related with the AR. Augmented reality, one of the student group is working on the augmented reality project, and that is also for the factories and warehouses. So these are our different publications and research. Next please. These are the different undergraduate, postgraduate and PhD level courses which we have included in the curriculum of mechanical, manufacturing, materials and metallurgy engineers. And you can see that the smart manufacturing, sustainable manufacturing, applications of AI in manufacturing, data analytics, and these are the courses which are needed for our students. As I told you that these are the requirements of the modern world, and in next 3 to 4 years, the demand of the engineers will be dependent if they have these all knowledge areas embedded in their curriculum. Next please. Yes, so this is my contact. If you want to contact, please scan this QR and we'll be in touch. Thank you very much to the UniMAP management who provided us this space to be here and present our presentation. Thank you very much. Assalamu alaikum.
Thank you very much for the great sharing. Next, we will proceed with our next keynote speaker. I'm honored to share a brief background of our keynote speaker for today. Technologist Dr. Salfarina is the Head of Research and Development at PHN Industries Sdn Bhd, holding a PhD in Manufacturing Engineering. She leads PHN Transformation towards sustainable manufacturing, previously covering end-to-end tooling development from design and simulation to fabrication, testing and production integration. Currently, her initiative includes the development of new products for both automotive and non-automotive sectors, as well as IoT and AI-based device, strengthening PHN position as an innovation-driven industry leader. Without further ado, please welcome technologist Dr. Salfarina binti Rosman to share her keynote speech titled Crossing the Invisible Line, a Journey of Transformative Research in Digital Innovation. Please welcome.
Bismillahirrahmanirrahim. Associate Professor Technologist Dr. Nurhatiza binti Muhammad, Chairman of International Conference on Digital Transformation and Emerging Technologies, ICD TET 2026. Honorable distinguished professors, researchers and delegates, and also the students. Thank you for the kind invitation to the International Conference on Digital Transformation and Emerging Technologies, ICDTET 2026 at University Malaysia Perlis, with the theme Transformative Research in Digital Innovation and Technology Change. It is a privilege to join this esteemed gathering, and I look forward to meaningful engagement and knowledge sharing throughout the conference. Okay, before we begin, let me introduce myself. My name is Salvarina. So my experience, this is my education. My degree is manufacturing, my master also manufacturing, and my PhD also manufacturing. This is the certification from the RB HiCom Culture Transformation Practitioner into specialist of CATIA designing and also professional technologies and towards the engineer, inshallah, this year. And this is my experience. So I have been in the industry 23 years already. So there's a lot of things that I like to share regarding the title. Since all the, I believe 90% of the audience is, I believe, the students. So this keynote little bit tweak for you guys to understand what is actually transformative research. Okay, let's talk about resistance. I believe all of you understand what is resistance. Resistance is a system that stops motion of motors. For example, in the system, in this transformative digital innovation resistance, it limits transformation, meaning that if there's a resistance in transformation, it limits it. So, in my experience, 23 years in the industry, I noticed that technology do improve, but the transformation looks like slow. I believe all of you understand what is technology we're talking about. Just now, Prof. Wasif gave a very nice presentation about all the technologies emerging right now. Artificial intelligence, IoT, digital twins, there's a lot of technology. However, technology do improve, but the transformation does not improve proportional to technology. So what is the core challenge? The core challenge is that digital technology innovation is today is very impressive. Yet many initiatives not able to transform to a real system. So I think this mic is actually constrain my movement. Can I change? Can I move it? Can I take it up for meeting? What if I take this? Because I'm very short, just like it's too high for me.
You want quarters?
You have it? Okay, good. Restrict my movement actually. You see, transformation resistance. Now we are okay, alright? Okay. So, as Professor mentioned just now, there's a lot of technology here in the world. However, it's not necessarily proportional to the transformation. Why? Because of the resistance. I'm sharing with you is based on my personal experience. There's a gap between innovation and impact. As I mentioned just now, there's a lot of resistance. When you try to explore new technology, there's always a system pushback. So in other words, it's not easy to transform from your theory, from your research to the actual application. It seems nice in the paper, it seems nice in the research, but it's not as nice when you actually put in the actual application. So this is based on my experience. There's a pattern. Okay, the central metaphor is that mechanical resistance. So how I want to read this one? Quite far from it. Okay, I try to sit here. Okay, all right. Mechanical resistance where motion is constrained. in a positive way, is that resistance is not necessarily negative. In our engineering theory, if we know resistance, then we know where is the stops occur, right? So, and system resistance is where when the transformation slows. So if we know there's a resistance there, we know where to tackle the issue. So, the first step is you must identify what is actually the resistance, what is actually the challenge. So I understand this throughout my engineering journey. We start with when I was a designer, and I shift to project manager, and then the head of tooling, and last head of R&D. From my experience, my understanding about research evolved with the role. So, what good research actually means? So we start with the phase of designer. Invisible resistance. There's a lot of digital innovation occurred in as a designer, right? Mr. Nizam here is industrial designer. CAD, CAE, CAM, digital twin. There's a lot of good design and good technology. I thought if I do very good design, then of course the technology will be accepted. But I am wrong actually. It's not as easy. We think that the design is good, but the system is not doing good. Why? Because the invisible resistance of sharing design to the actual application. I think the design is good, but we come to the actual application, there's a lot of issues. Machine issues, purchase issues, common issues, and adaptation of previous concept also. So, my first conclusion is that the design works, but the actual situation struggle. So, the conclusion is that good technology does not guarantee system acceptance. And then I go to the project management phase. Okay, now I got the resistance of time. As you all know, research in university, there's a long time, you have time to explore. But in actual industry, you don't have that enough time. So time is the resistance. So when I have all the digital innovation there, I have dashboard, I have real-time tracking, I have some tablet to monitor my progress as project manager. But in actual, the system does not transform because there's a time challenge. I think I can do best, but when the time's resistance there, we cannot make the perfect condition. As long as we can release it, then we release it. That's where the time becomes the resistance, the time becomes the challenge. And time is built in project default. And we have to know how we want to cross it, how we want to reach our deliverables within the given time. So that is the challenge during project management phase. And research that ignores time challenge really rarely survive implementation. Right? Then we go for the tooling phase. Now resistance becomes physical. I have wear, downtime, rework, everything you name it in actual implementation. So now I'm fighting the system. Please accept my development. Please accept my research. But existing system is not as easy that we can think we can offer new technologies. So this is where the system resists, where the resistance becomes physical. This one, it gradually fails. At the first phase, we think that it's very good. By the time goes by, when it merging with actual system, it fails. Why? Because not all the actual application accept our research, our new technology. There's a lot of challenge there. So it gradually fails. By the time failure is visible, resistance has already accumulated. And the last one, for the research in the area of R&D. So now is the biggest decision resistance. What do I mean by decision resistance? You have your technology, you have your research. So who can decide for you? Yes, we want to implement it. Yes, we want to invest in it. Yes, we believe in it. This is decision resistance, the biggest resistance ever for a researcher. And this one, the hardest resistance to remove is not technical, it's decisional. No matter how good your research is, but if nobody believes you, nobody want to take your research to actual application, and there is where your challenge is. And research does not transform system, decision do. For example, you have a lot of research. I believe all here will be present your paper tomorrow. So there's a lot of decision need to be made. There's a lot of selection. So decision resistance. Your technology may be good, but which one is the best? And which one will be selected as the research that confident? The invisible line. This is what I call the invisible line, as I mentioned in the title. There's a phase there: principle, prototype, pilot, plan, and policy. The famous terms, I believe all you know, all of you understand about technology readiness level. There are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So where is the invisible line? The invisible line, the first one, technology layer. Second one is the system layer, sorry on the typo, human layer, and the decision layer. The transformation phase, your research transformation happens at the end. Usually, research can pass technology layer, not necessarily can pass the system layer, and sometimes can pass human and decision layer. And transformation happens only after each line is crossed. So in terms of this conference, there's a lot of different topics. I have run through all your topics. It's very nice, very impressive, it's very good. There's a lot of topics, different topics in digital innovation, different methods, but shared intent. This is all the topics, the one that are mentioned by Dr. just now, Dr. Nafriza. So this is all the topics. All have shared intents. What is the shared intent? The shared intent is that to reduce resistance, to reduce the challenge, either technical, system, human, or decision resistance. So, I believe all of your research is toward transformative research. So the key takeaways, after all my sharings here, what is the key takeaways? The first one is that identify where resistance exists. So in your paper, I believe all of you have what is your problem statement, what is your problem challenge. That is your resistance. And then where the system resistance. You have to understand actually what are you trying to solve and what happened if this research success. So you have to understand that. And then it's not designed for accuracy. It's not designed for action, for accuracy. Actually, it's designed for action. So I understand all the research team usually is towards the result. But what is the next action actually? What actually you want others to do based on your research? And then, please cross at least one boundary. Just now Prof. was mentioned about all the technology, please cross. Do not lock for one expertise only. So you need to cross it, and if possible between disciplines, roles, insights, and decision. Just now you remember the graph that Prof. Wasim mentioned. There's a lot of new era, new tasks that emerge. So you have to cross that. So that's the key point that you have to remember. And then the research, if you can do this, your research, inshallah, will be transformative. So back on the title of Crossing the Invisible Line, a journey of transformative research in digital innovation. So transformative research is measured not only by what we discover, or what you discover is called research. Now we are talking about transform. You know about Transformer? Right? The movie Transformer is transform. So how you want to transform? You research. So what decision it change? What workflows it reshapes? And what technology it accelerates? Lastly, into real world impact. So last for you, it can be reached only where we can clearly answer one question. Tomorrow I will ask you this, yeah? Okay? Which decision or workflow will change because of your research exists? Okay? With that, thank you.
Thank you very much, Dr. Safarina, for the nice sharing. Ladies and gentlemen, we already come to the end of the opening ceremony. On behalf of the committee, I wish to thank all the distinguished guests and participants for spending time with us on this wonderful day. We hope that this conference will serve as a meaningful platform for knowledge sharing and productive engagement, and that all participants will benefit greatly from the session ahead. With that, ladies and gentlemen, the opening ceremony is now officially concluded. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh. We will have a photo session.
Kita bagi nampak background dulu nak. Okey, boleh.